All right, Math 2, here we go. We got lesson 5.1.1, investigating graphs of quadratic functions. This is like a 2-day lesson, but we're just going to do it all in one. So when we have a quadratic function, which is basically any function where the highest degree of the terms is an x squared. So when we have these graphs, we've seen in some of our homework earlier in Unit 4 that these are going to make parabolas. They're going to kind of make U-shapes. So here I've got x squared minus 2x minus 8. And we're going to just plug in a bunch of x values, get the output values, the y values, and they're going to go ahead and graph them and see the parabola shape that it makes. All right, so if we plug it in, -5, remember you're going to square -5 times -5, that's going to become positive 25. And then -2 times -5, that's positive 10. And then minus 8. So that's 35 minus 8, which would be 27. Plug in -4. So -4 times -4, remember that's positive 16. And then -2 times -4 is going to be positive 8. And then minus 8. So this one we get 16. -3 times -3 is 9. -3 times -2 is positive 6. And then minus 8. So here we're getting 7. All right. -2 times -2 up there, that's going to be positive 4. And then -2 times -2 is also positive 4. And then minus 8, looks like we're getting 0 on this one. -1, let's plug it in. We get 1. -1 times -2 is positive 2. And then minus 8. So we're getting -5 right here. Plug in 0. This one's easy. 0, 0, -8. Plug in 1. We get 1 minus 2 minus 8. So that would be -9. Plug in 2. We get 4 minus 4 minus 8. So these cancel, I get -8. Plug in 3. 9 minus 6 minus 8. Looks like -9 minus 6 minus 8, -14. -5. Losing my mind. Number 4. 4, we get 16 minus 8 minus 8. Oh, that's easy. That's going to be 0. And then we plug in 5. We get 25 minus 10 minus 8. So here we get, what's that, 7? All right, so here's what I'm noticing on this one. I'm getting these values, and it looks like on either side of this value here, we're getting the exact same outputs. So here I've got -9, but on either side it's -8. On either side of that, it's -5. On either side of that, it's 0. On either side of that, it's 7 there. So this is what you're going to see when you do a quadratic. You're going to get this parabola shape because on either side of one, you're going to get what we call symmetry, where it's the exact same number on either side of something. Let's go ahead and graph this real quick. Where's my ruler? There it is. All right, so let's graph this bad boy. We'll put it here-ish. That looks good. And what do we got? About right here? I'll put it right here. That looks about right. All right, so let's go ahead and graph this. I'm going to go ahead and start graphing it right at this point here, where we see that this is probably like the lowest point. So that's 1, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's 1, -9. And then I've got 0, -8. 1, 2, 3, 4, 5, 6, 7. Yep. And then on the other side, I've got 2, -8. So there's that U shape that we're starting right there. See right here, there's the U shape. And then on either side, we've got 3, -5. And over here, we've got -1, -5. And we're continuing that U shape. Definitely not linear because the rates of change are changing. Okay, then I've got 4, 0. There's 4, 0 right there. Then I've got -2, 0 from this one right there. And the U shape continues. That wasn't very good, but we're going to give ourselves some grace on that one. All right, let's keep on going. So at -3, 7, 1, 2, 3, 4, 5, 6, 7. And then over here at 5, 7. All right. And then over here I've got -4, 16. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now we didn't get the value of 6 in here when we plug in 6, but I can make the assumption that if I plug in 6 for x, I should get 16 because we've got this reflectional symmetry on either side here. So I should assume that I get 16. Now here's one of the nice things about graphing or parabola is if you know where your vertex is, where the lowest point is, if you get a value on one side, you're automatically getting a value on the other side. It's like a 2-for-1 deal here. All right, so let's finish off. This is pretty hard to do. There we go. And there. All right, so there's our parabola that we've graphed. We've noticed in graphing this that we're going to get a lowest point here. And then on either side of the lowest point, we've got the same y value on either side of it. And that's what's making the U shape. Okay, now we're going to describe the characteristics of the graph. So this is definitely a U shape. And this particular U shape is doing what we're calling opening up. The U is opening up. It is possible to have a U shape that faces down. So this one opens up instead of opening down. So it's a U shape or parabola that opens up. The x-intercepts, we've got 2 of them. We've got an x-intercept here and here. Now these are when the y values are 0. So right here, my x-intercept is -2, 0, and my other x-intercept is 4, 0. So sometimes you can just say that your x-intercepts are -2 and +4, or you can state the actual coordinates, which would be -2, 0 and 4, 0. So anytime we have an x-intercept, the y value is 0. Now we do have a y-intercept right here. This is where the graph crosses the y-axis. And instead of the y being 0, the x is 0 at this point. So the x is 0, the y-intercept was -8 there. So we can say that the y-intercept is -8, or we can state it as a coordinate, which would be 0, -8. The vertex is the lowest point of our graph, or if it's facing down, it'd be the highest point of our graph. So we would say for this one that our vertex is 1, -9. That's our lowest point. We would also call that the minimum of the graph since it's the lowest point. It's the minimum value that y could be. So we would also call this a minimum. The line of symmetry. So the line of symmetry is the line where if you did a reflection, that it would create the same object. So the line of symmetry would be a vertical line that goes through the vertex. So I'm going to make a dotted line here. So that's our line of symmetry right there. And we can see that on either side of the line,
we have what's called reflectional symmetry, that if you reflect across, you get the same exact shape. So this is called a line of symmetry, and sometimes it's also called the axis of symmetry. Depending on what book you're using, they're basically the same thing. So the line or the axis of symmetry. Now, this is a line, so we need to write it as an equation. So a lot of people will go, oh, it's 1, but it's an equation. So the equation of that vertical line is x equals 1. So remember that your line of symmetry also always has to have an equal sign because it's the equation of the line. And since this one is a vertical line, it's always going to be x equals whatever number it's passing through on the x-axis. Domain. Domain are all the possible x values. Now, I can keep on plugging in x values and getting new y values. There is nothing stopping me from getting new x values to plug in. I can plug in any x value I want. So for this one, we would say the domain is all real numbers. So the domain is the set of all real numbers. The range. The range are the y values. Now the range does have some limitations. So our y values, I can see here with these arrows that it's going to go up forever. So our range up here is unlimited. It's going to keep on going forever and ever. But there are some values that our y values are never going to hit. We can see here that we had a lowest point at -9 because range we're talking about are y values. So I'm never going to get below -9. So my range values have to be 9 or any y value bigger than 9. So when we say the range for this one, our range is going to be the set of the y values that are bigger than or equal to -9. So there's our range values there. All right, part C. What if we factored this thing? What do we notice about our factors if we looked at it in factored form? So for this one, remember factoring, when we don't have a leading coefficient, we can just say, okay, what multiplies give us -8, but adds to give us -2. So what's multiplying to give me -8, adding to give me -2, that would probably be -4 and +2. Because -4 times 2 is -8, -4 plus 2 is -2. So this one would factor into x minus 4 and x plus 2. So there's factored form. And here's what I noticed about factored form. I've got -4 and +2, and my intercepts were -2 and +4. They're opposites. So my x-intercepts are the opposites of these values inside of my factors. So the x-intercepts are opposites of the values in the factors. Is there anything else that you notice about the graph and the equation? Well, I do notice that this -8 was our y-intercept. And it makes sense because if you plug in 0 here, the x's basically just go away. So this -8 value over there is our y-intercept. So let's do a different color. So this value right there, the value that's a constant that doesn't have a variable, that is the y-intercept. So our equations are going to give us our y-intercept when we are in this format. We're going to call that standard form. And if you factor it, you're going to get your x-intercepts. At least the opposites of these values are going to be your x-intercepts. All right. So last thing we're going to do real quick is, this is like day 2 what we would do, is we're going to just pick a function that opens down instead of opening up. So that last one, the U shape opened up. It had a minimum. Now we're going to do one that has a maximum. So on this one, I am going to choose, let's see, I'll choose y equals negative x squared plus 3x plus 4. All right, real quickly, let's just start plugging in these values here. So if I plug in negative 5, remember negative 5 times negative 5 is 25, but then the negative outside makes that a negative 25. So negative 5 times negative 5, positive 25, and then this switches it to a negative. 3 times negative 5 is negative 15 plus 4. All right, so this one I've got negative 40 plus 4, which would be negative 36. Now we're going to do it for negative 4. So negative 4 times negative 4 is 16. Then I make it negative. That's negative 16. 3 times negative 4 is negative 12 plus 4. So this is negative 28 plus 4, which is negative 24. Plug in negative 3. Negative 3 is 9. Make it negative. That's negative 9. 3 times negative 9 is negative 9 plus 4. So this is negative 18 plus 4, which is negative 14. Negative 2, negative 4, negative 6 plus 4, that's negative 6. Negative 1, 1 times 1, negative 1. Negative 3 plus 4, there's 0. Plug in 0. That's easy. It's just this value here. That's 4. That is our y-intercept. Plug in 1. 1 times 1, and then I make it negative, so that's negative 1 plus 3 plus 4. So that looks like a value of 7 minus 1 is 6. Plug in 2. I get negative 4 plus 6 plus 4. So that's a value of 6. And then plug in 3. I get negative 9 plus 9 plus 4. I get 4. Plug in 4. I get negative 16 plus 12 plus 4. That would be 0. See what's happening here? Same, same. And then the next value should give me negative 6. I'm going to just call that early, and let's see if that happens. I get negative 25 plus 15 plus 4. And yep, so these two give me negative 10. Negative 10 plus 4 is negative 6. So I do see that I'm getting that same thing. Now this one's a little bit weird. We're not getting a middle number. It's just these two are reflected right here. That means that our vertex is right in between those 2 points. So right in between it. So at 1.5 or 3 halves, that's where our vertex would be. Okay, graphing it real quick. Stupid lights. All right, so graphing it. We're going to do this. Let's see. Okay, so we're going to graph it. Let's see. Yeah, about right here-ish. That looks about right. All right, so graphing this bad boy, we're going to put, where's that other pen? There's my other pen. All right, so we're going to graph 1, 6, and 2, 6. So 1, 1, 2, 3, 4, 5, 6, and 2, 6. All right, and then we're going to plug in 3, 4, and 0, 4. 1, 2, 3, 4. 0, 4, here's 3, 4. And then negative 1, 0, and 4, 0. And let's see, 5, negative 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. We're going to just stop right there. So we're graphing this. Now our axis of symmetry on this one is going to be right down the middle here. All right, so what it looks like is happening here is that 3 halves, 1.5, that's where our vertex is. Now our vertex we didn't actually find there, so let's go ahead and find that out. So if I plug in 3 over 2, because that's between 1 and 2, if I plug that into my equation, let's see, 3 over 2 times 3 over 2 is 9 over 4, so that's negative 9 over 4. And then 3 times 3 halves is 9/2, and then plus 4. Let's turn these into decimals. So this one would be negative 2.25. This would be positive 4.5. And then plus 4. So let's see, 4.5 minus 2.25 is 2.25. 2.25 plus 4 is 6.25. All right, so our vertex is actually right, oops, wrong color, is right about here at 6.25, which kind of makes sense for this. It looks like that's making the U shape there. All right, there's our parabola. So what's the shape? This one's a U shape that faces down. Or opening down. The x-intercepts, we do have the x-intercepts. Remember, that's when y is 0. So we've got -1 and +4. -1 and 4, which are the points -1, 0 and 4, 0. The y-intercept, that's when x is 0, so the y-intercept's at 4. And that's the point 0, 4. The vertex, we had to find that by going halfway in between these two values right here. So we found out that the vertex was at the point 1.5 and 6.25. Line of symmetry. Oops, there you go. So the line of symmetry is x equals 1.5. That's that blue dotted line that we made right there. Now notice that the x value of the vertex is also this value in your line of symmetry, because the line of symmetry is always going to go through that vertex. Our domain, all real numbers. Our range. Now this one's a little bit different from the last one that we did, because here I can see that my y values are never up here. They're always at this point or below. So our y values are less than or equal to that highest point, that maximum, which would be 6.25. So I can see here that if this on my vertex was my same number as my line of symmetry, I notice that this number is the other part of the vertex. So our range is the, in this case, the highest point. It's the number that we're going to use in our range right there. Now, if I factor this one, let's look at this real quick. If I factor y equals negative x squared plus 3x plus 4, for factoring this one, you don't want to factor when the x is negative. So I'm going to factor out a -1. So this is going to be -1. This would change into positive x squared, negative 3x, and -4. Why negative 3x and -4? Because if I multiply this back out, I should get what I started with. So really what I'm doing is I'm dividing all of these by -1, and this is what I'm getting as a result. Because -1 times x squared is negative x squared, -1 times negative 3x, positive 3x, -1 times -4 is positive 4. So now I'm going to go ahead and factor this. So what multiplies to give me -4, but adds to give me -3, and that would be -4 and positive 1. So this one factors into -1, I already factored that earlier, and then x minus 4 and x plus 1. Now remember what we said, if we look at the opposites of these numbers, positive 4 and -1, those are my intercepts. And also this number right here is my y-intercept. So the opposite of these factored numbers is our x-intercept, and then this value, we call it the c value, is my y-intercept there. So what I notice is that if I have a negative x squared, we've got a parabola that faces down. If I have a positive x squared, we're going to get a parabola that faces up instead. All right, that's all I got for you today. We'll get a little bit deeper into this a little bit later. See you later. Bye-bye.